Hey, what's going on, guys? I am back once again with a brand new video for you, Unit 14 test review. Um, hey, check out my new logo, man. Hopefully, y'all like that. Try to switch it up a little bit. New track as well. Hopefully, you like that. But anyway, hey, the main thing is I want you to do well in this test tomorrow, so please use this reference to study. All right, and I will. Hey, really, look, I just hope it helps us, okay? All right, for this first example right here, it says the probability distribution for the number of defects in a shipment of alarm clocks based on past data is given below. Find the expected number of the defects in the shipment of alarm clocks. So what you got to do is, first of all, you want to make sure all these right here at the bottom add up to 1. All right, that's going to be our bottom. All right, so actually let me use this tool right here to make a straight line because you guys know I can't write that well. I think that'll suffice. So what we got here is at the bottom we're going to have 0.82 plus 0.11 plus 0.04 plus 0.02 plus 0.01. Alright, and then at the top right here we have, you're going to multiply the number of defects, or your n times its percentage. Alright, so you have 0 times 0.82, alright, plus 1 times 0.11 plus 2 times 0.04 plus 3 times 0.02 plus 4 times 0.01, like that. All right, and when you do so, at the top you get 0.29, and at the bottom that needs to be 1. Okay, so when you simplify that, it's just 0.29 defects. All right, or 29% defects. Ooh, CTS. Dude, I totally butchered that. Let me try that again. 0.29 defects. Like that. All right, 0.29 defects. All right, right here, the following data set represents the age of employees at the movie theater. All right, it says find the mean, the median, and the mode of this data set. All right, to find the mean, and guys, listen, you can literally plug these into your calculator and do them. All right, so let me bring up my calculator. All right, so we have, let's see here, we're going to press stat, all right, and then edit. Then we're going to put our points in this list right here. Let me clear the list out. All right, so the numbers we have are 17, 23, 18, 22, 45, 28, 22, 25. All right, so there's our list. Now we press stat again, go over calculations, one variable statistic. All right, and you should have this stuff right here. All right, the mean is X bar. All right, so the X bar is 25. The standard, what does it mean? Oh, median. The median would be, scroll down right here, 22.5, and the mode is going to be the number that appears the most frequently. So let's go back to our other screen. So we saw that our mean was 25. The median was 22.5, and the mode, if you look, which number appears the most is going to be 22. So the mode, guys, is 22. All right. Now right here it says make a box and whisker plot the data and find your interquartile range. Well, making a box and whisker plot, guys, using those points is really simple. All right, if we go back to our calculator, right here you will see your 5-number summary, right? Your minimum is 17, your maximum is 20, 22.5 is your median, 26.5, and then the max is 45. All right, so the minimum we said is 17. So 17 is right here. The maximum is 45. Now, the lower quartile was 20, or the first quartile was 20. The median was 22.5, so that would be right here. 22.5 is right there. And then the upper quartile was 26. That's right here. Alright, so there we go right there. We connected. Man, this line's terrible. That one right there. Okay, so now the next thing we got to make is the interquartile range. That's IQR, interquartile range. The interquartile range is going to be Q3 minus Q1, or in this case, you have 26.5 minus 20, and that gives us a strong 6.5. All right, so the interquartile range is 6.5, guys. All right. Now we've got this number 3 right here. It says the data set shows the amount of money routed to the nearest dollar spent by 20 consecutive shoppers at a home improvement store. What is the population? What is the sample? All right, let's look at what is the population. All right. The population would be, given this case right here, the shoppers at this home improvement store. This would be the shoppers at the store. I'm gonna type that in because my handwriting again is just not the greatest thing in the world. So the shoppers at the home improvement store, and they're the population because, because that's what we're observing, right? We're looking at the money that those people spent. All right, the home improvement store. Now the sample is going to definitely be the 20 shoppers. All right, because we can't look at all the shoppers in a day. All right, so we're going to look at just the 20 shoppers. That these specific 20 shoppers in a row. All right, let's just find the mean and the standard deviation. Well, again, this is another problem. Excuse me. We can use the calculator. Okay, so I'm going to change back to the calculator. All right, so now I go stat and then edit again. I'm going to clear my list out. All right, so now the list is cleared, so I'm going to punch in those prices, right? So you got $35, $18, $49, $55, $280, $29, $42, $61, $19, $80, $33, $45, $67, $28, $71, $37, $48, $50, $31, and $22. All right. Awesome. So now we have stat, edit. I want to calculate this thing again. All right, so the mean is 55. It says what's the mean, and the standard deviation is 54.31. 54.31. So let's have a look here. All right, we said that the mean was 55, and the standard deviation is 54.32. All right. Now it says find an outlier and describe how it affects the mean and standard deviation. All right, so first of all, in order to do that, we need to find 3 standard deviations. All right. So to do that, we have 3 times sigma, all right, or 3 times 54.3. And we do that, you're going to get 162.96. So let me write that in. 162. Alright. Now, we need to do 3 standard deviations above. So we take the mean plus 162.99. Wait a minute. Let me make sure I wrote that right, because I don't know if I wrote that right. 162.96. Yeah, 162.96. I wrote 99. So let me fix that. And again, 3 times sigma. Well, I just dig sigma. This is sigma. So it's 3 times 54.92. Sigma 54.32. Alright, so 3 times 54.32 is going to be 162.96. So if I add 55 to that, alright, we get 217.9. And if I subtract 55 minus that, well, I'm not even going to worry about this because this is going to be a really large negative number. And we're not looking for it. Like, we're looking at people that spent money. All these people spent money. So the negative really doesn't matter here. All right, well, actually, let's go ahead and do it. We'll just do it just for the sake of having that instruction. So if we go 55, oops, sorry about that. If we go 55 minus that answer, 162.96. All right, we get negative 107.96, negative 107. Now, we have our two limits, all right, for this thing. We have, there's the minimum, and here's the maximum. All right, so anything inside of that range is good. Anything outside of it is an outlier, okay? All right, so when we look now, we see that anything larger than this, all right, this is 3 standard deviations above. Anything larger than that, which is 280. All right, so 280 is the outlier. All right, 280 is the outlier. And then it says, how does it affect the mean and the standard deviation? Well, what we need to do is go back to our calculator and take the outlier out. So that's what I'm going to do. So here back at the calculator, we're going to press stat and edit. Go find the outlier, which is 280. And you can just hit delete right here to delete it out. And then stat, calculate. We're going to recalculate all these statistics. All right. Now, what is the mean? All right. The mean now is 43.15 or 16, 43.16. Let's write that down. And sigma is, let's see, what's the standard deviation? 17.34 or 35, 17.35. All right, so this is without the outlier. If I take the outlier out, so on the test tomorrow, make sure when you see a question that says describe how it affects it, well, just show with the outlier. All right, with outlier. All right, what was the mean? All right, 55, and what was the standard deviation? 54.32. And then over here show without outlier. All right, and this would be the stuff without the outlier. All right, so you do that. One with, all right, one with and one without. All right. All right, let's keep going real quick. Number four says, and online, let's read the direction. It says, decide whether a sampling method could result in a biased sample. All right, and explain your reasoning, okay? So I'm going to type all these because, again, my handwriting can be a bit atrocious at times, all right? So we're just going to type this thing. So, all right, an online store sells and sends an email message to its customers asking them to fill out a short customer satisfaction survey. So let's see here. Is this biased or not? Well, could all their customers have the same opportunity to be represented is what you got to ask yourself. All right, let's send another email. Well, what if the customers don't even provide an email? Or what if the customer's email send it to the junk file? They never actually read it. So I think this is going to be a biased. I think this could result in a bias. All right, I'll say that could result in a biased because I'm gonna abbreviate because right there. All right, some customers might not check their email, all right, or did not provide the store with their email. All right. All right. Oh, and you know what else will make this a bias? Because think about it. Have you ever really replied to a survey that you saw that you did get? All right. Unless you were like really happy about it or really really mad. That's the only time you will reply to it. Because think about it. If you got too few nuggets at Wendy's or McDonald's, then you complain. You see what I'm saying? So that you would be a bias because you're mad about something. And the survey might not be genuine, man. So. Let's see. Only those who are passionate will respond. Ooh. I like that. Only those that are passionate will respond. So this can be a bias, guys. Let's make this smaller. All right. All right. Number 2. A coach asks every player on the basketball team if they think after school sports should be required for all students. Oh, that's definitely a bias. That's definitely going to be a bias. And here's the reason why. Because the coach is already asking athletes. All right. He's already asking athletes. All right. So that's bias, guys. Okay. Now, this next one says the city conducted a survey about the city's home-based recycling plan. All right, so it's asking about a recycling plan at your home by contacting and questioning each of a randomly chosen sample of homeowners affected by the plan. All right, and I'm gonna say that's not biased. Man, I almost misspelled that. All right, it's not biased because, again, I abbreviated because right there. Randomly selected from all homeowners in area or affected. All right, so this was not biased, guys, because the key thing is it says they contact and questioning each of a randomly selected sample of homeowners affected by the plan. So the people that's going to be affected by the plans, they called and asked them. All right, then they didn't use the whole population. Like, remember up on this question where we didn't ask every shopper in the store, but we used the 20 that came after, the 20 consecutive, 20 random shoppers. But right here, guys, like you asking the people that's affected. So does everybody affected by the plan have an opportunity to be represented? Yes. And then they chose a smaller sample size and use that. So that is not a bias, okay? Now, let's look at number 7. Number 7 says a company employs 250 people. In a survey of 30 randomly chosen employees, 12 said they would prefer a company-sponsored lunch, while 18 said they would prefer a company-sponsored breakfast. All right, so it says describe the statistic. Well, we got a couple statistics going on, all right? The first statistic we have is going to be the people that said the lunch, right? The lunch crew, all right? 12 out of 30 said lunch. That's a stat. All right. For the breakfast, all right, that stat would be 18 out of 30, right? And then both of these we can reduce. 12 out of 30, they both, you can divide by 2, so that's going to be, actually, we can divide both of these by 6. So 12 divided by 6 would be 2, and 30 divided by 6 would be 5. And this one right here, 18, you can divide both of those by 6, and you're going to have 3 over 5. Okay, so I just reduced them. I'm sure we're going to need that in a second. Now, for this next one, it says describe the parameter. Well, remember, statistic is associated with sample. All right, so the sample size is 30 people. All right, and then the stat was 12 out of 30 and 18 out of 30. The parameter is associated with population. All right, so with that being said, we need to set up a proportion. All right, so describe the parameter. I'll just describe the parameter of the population would be 250 people. All right, the parameter is 250 people. Now, right here it says predict the number of employees who would prefer a company-sponsored luncheon. So luncheon, we will look at this one. All right, we set up our proportion. We have 2/5, and we're going to set that equal to X out of 250 because we don't know. Now, of course, you're going to cross multiply, right? Cross multiply. All right, so 2 times 250 is going to give us 500, and 5 times X is 5X. Then, of course, we're going to divide by 5 on both sides, and we see that X equals 100. So about 100 people prefer the company-sponsored lunch. All right, 100 people, okay? All right, last 3 problems. Let's see what we got here. It says explain whether each research topic is best addressed through an experiment or an observational study. Then explain how you would set up the experiment or the observational study. So it says, does exposure to X-rays affect vision? I think that would definitely be an observational study, because remember, the key thing about experiments is it ethical or unethical? All right, well, we don't want to try to enlist people to go, hey, let me test and see if your vision is going to be affected by this, because if it is, then I'm held liable for that, and I don't want to be held liable for that. All right, so we're going to say that this is definitely an observational study. All right, definitely an observational study. All right, observational study. Now, how will we do this observational study? All right, this is the question that we got to ask, okay? So how will we do this observational study? Let's see here. Observe patients, right? I misspelled that. Observe, not on the serve. Observe. I don't even need that right there. Observe patients who get X-rays and test their vision, right? All right, there we go. All right, we'll do an observational study, and then we're going to observe patients who gets X-rays and test their vision to see if it's affected. Very simple. All right, for this next one, it says do a particular gasoline additive affect fuel economy. All right, so let's see here. We can do that as an experiment because I don't really see that as unethical. All right, I don't know what the harm and foul would be in testing gasoline. All right, so we'll say experimental right there. All right, and anytime you say experimental, then you must have a treatment group, and all right. Well, first we gotta have a treatment. The treatment will be the additive, right? The additive to the fuel. All right, or to the fuels. All right, and then the treatment group would be the gasoline with the additive. Oops. Additive. Man. Now, the control group, because remember, you must have these three things whenever you do an experiment. The control group would be the gas without the additive. Now, how would you do it? All right. I would take, I don't know, man, 1,000 gallons of gas. 500 gallons will be treated, and 500 gallons untreated. All right. So 500 gallons treated, 500 gallons untreated. All right. And then what do we do with all that treated gas? Well, an untreated gas. We will put it into a car and drive until it runs out and see how many miles we get on full tanks. Right. All right. We see how many miles we get on fuel tanks. Okay. All right. Last one. All right. A psychologist wants to determine if working below fluorescent lights could cause lethargy. All right, lethargy. At a particular company, new lights are installed where half are fluorescent and half are incandescent. A month later, workers took a survey about their energy level while at work. Tell if it is an observational or experimental study and explain why. All right, well, guys, listen. This one, obviously, I think it's obvious. It's going to be an experiment. All right, it's an experiment. And I'm going to tell you why. Because there's a treatment being done. All right, there's a treatment. Oh, this thing again. There's a treatment being done. All right, and the treatment are the fluorescent lights, because they're trying to see. Oops, fluorescent. I still misspelled it. All right, the fluorescent lights. All right, are the treatment. All right, and then the treatment group, of course. Here's the group. The group working under the fluorescent lights. Man, I misspelled it again. Flower scent. Ah! Oh, that's terrible. I went to college, y'all. Alright. Anyway, that's sarcasm to myself. And then my control group would be the group working under the incandescent lights. Alright. Yo, that is it. This is the video. It went way too long. But you know what? I'm okay with that because I feel like we got some good stuff in here. It was kind of thorough. I really want you guys to do well on this test. So listen, please use this as a resource, a study resource, and I hope it helps. And yo, share it with anybody else that needs it from another class as well. I want everybody to do well. And Coach Moore, we'll catch you later. Peace.